In this lesson, we're going to look at how we can apply quadratic equations to some word problems. We're going to start out by looking at some area problems. So looking at number 1, given the diagram below, find the value of x if the area of the rectangle is 78 square meters. So we already know how to find the area of a rectangle. We know that that is length times width. In this problem, we know that our length is x plus 7 and our width is x. So if we were to set up an equation to show that, x times x plus 7, so our area, length times width, we know equals 78. We can use this equation that we've written to help us find the value of x. The way we're going to do that is by distributing the x to inside the parentheses. That would give us x squared plus 7x equals 78. Then we need to bring our 78 term over, which would give us x squared plus 7x minus 78 equals 0. So now this is a quadratic in standard form. And when a quadratic is in standard form, we know how to factor it. In this particular quadratic, we can factor it as a basic trinomial, where we find two numbers that multiply to give us negative 78 and combine to give us 7. So we're going to set that quadratic up with two binomials set equal to 0. We have x and x. And if we think about two numbers that can be multiplied to give us negative 78 and combined to give us 7. So since we're multiplying to get a negative and combining to get a positive, our two numbers need to be one positive and one negative. And since our combined number is a positive 7, our largest number needs to be a positive. So those two numbers would be positive 13 and negative 6. Now that it's factored completely, we can set up our work area and set each binomial equal to 0. So x plus 13 equals 0 and x minus 6 equals 0. And we find that x equals negative 13 and positive 6. The problem wants us to find out what x equals. Well, x can't equal both of these, but I can eliminate the fact that x equals negative 13. Because in my problem, my width can't be a negative number. So my final answer would have to be x equals 6. Because again, our width can't be, or any of our dimensions can't be a negative number. Go ahead and highlight number 2. And let's look at number 3. So number 3 is similar to number 1, but the problem is asking us for something different. Given the diagram below, find the dimensions of the rectangle if the area is 128. So in number 1, it wanted us to find the value of x. In this one, it wants us to actually find our length and our width. But we can use the same method to find it. So we know the area of a rectangle is length times width. And I know a length and width expression, so I can write an equation. My length times my width equals my area of 128. Then I can write this in standard form as a quadratic. In order to do that, I'm going to have to FOIL these two binomials. So first, outside, inside, last, bring down your equals 128. Remember, when we FOIL, you find that you always have to combine those two terms in the middle. So we get x squared plus 6x minus 7 equals 128. Then in order to put it in standard form, the 128 needs to be brought over to the left. And we do that by subtracting 128 from both sides. So that would give us x squared plus 6x minus 135 equals 0. Again, I'm given a basic trinomial. So to factor that, we have two binomials set equal to 0. And for this one, I need two numbers that multiply to give me negative 135 and combine to give me 6. So again, in order to get a negative, when I multiply, I have to have one positive and one negative. Well, in order to get a positive 6 when I combine, my largest number is going to have to be the positive number. So the two numbers that would make this true would be a positive 15 and a negative 9. Once that's factored, I can set each factor equal to 0. So x plus 15 equals 0 and x minus 9 equals 0. And I find that my solutions are x equals negative 15 and x equals 9. Well, again, just like with number 1, we can eliminate x equals negative 15 because I can't have a negative dimension. But we have to take this one step further in order to answer the question. So far, we've only found out what x equals. I need my dimensions. So in order to do that, I'm going to have to take the fact that x equals 9 and plug it into each expression. So I'm going to replace x with 9 plus 7. That equals 16. And then 9 minus 1, that equals 8. So my dimensions are 16 feet by 8 feet. So make sure when you're working these problems that you're reading what the problem is asking for and that you're answering that appropriately. Go ahead and highlight 4, 5, and 6. The next type of problems we're going to be looking at are projectile motion problems. Again, another way that we can look at quadratic equation word problems. A soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h equals negative 16 t squared plus 90t gives the height of the ball after t seconds. Find the maximum height of the ball and how many seconds will it take it to reach the ground. So this is going to be a multi-part problem. So remember when we talked about maximum and minimum, we used another word called vertex. So when it's asking you for the maximum height of the ball, it's asking you for the vertex. So we want to use that vertex or that axis of symmetry formula. Negative b over 2a. And then using the equation it gives us, we know that a is negative 16 and b is 90. So plugging that in, I get negative 90 over 2 times negative 16. Again, I'm using my axis of symmetry formula, and I'm using the formula that the problem gave me. So when I solve this, I get negative 90 over negative 32. And when I divide that out, I get 2.81 when I round that answer. So this is going to give me my maximum. But remember, this asks for my maximum height. What this gives me is my time. So this is telling me the time. So now what I'm going to have to do is take that time and substitute it into that equation in my problem, and that will give me my height. Because remember, the equation in the problem says h equals height equals. So in order to find the maximum height, we must first find the maximum time and then use that time to find the height. So using that equation, h equals negative 16t squared plus 90t, I'm going to replace both of these t's with 2.81. So that would be negative 16 times 2.81 squared plus 90 times 2.81. When you're putting this into your calculator, I would advise you to not put it in straightforward. I would make sure you do this 2.81 squared first, then multiply it by the negative 16, and then multiply 90 times 2.81. This is just going to help you avoid errors in putting it into your calculator. When you do put it into your calculator step by step, you get 126.56. So your maximum height is going to be 126.56 feet. So again, to get maximum height, first find maximum time, and then use the time to find your height. The second part wants to know how many seconds will it take the ball to reach the ground. Remember, when it's on the ground, your height is 0. So we're going to take our formula back at the original problem, and we're going to replace h with 0. And then my problem's asking me for seconds, which is time. So now all I'm left with is trying to solve for t. And if you notice, this is a quadratic set equal to 0. So in order to solve for t, I'm going to factor it. I'm first going to factor out a GCF. So I have a greatest common factor of negative 2t. And when I divide that, what I have left is 8t minus 45 equals 0. Then I'm going to divide my work area up and set each one of those factors equal to 0. So negative 2t equals 0, and 8t minus 45 equals 0. So on the left, that gives me t equals 0. And on the right, t equals 5.625. Remember, to solve all on the right, you want to add 45 to both sides and then divide by 8. Now, when we think about this, it wants to know how many seconds it will take the ball to reach the ground. So originally, the ball is already on the ground. So that's where we get the time is 0. The starting point, the ball's on the ground. But then it's kicked and come back down. So that wouldn't be our time. Our time would be 5.625. So after 5.625 seconds, that ball is on the ground. So again, both of these times are correct, but one is where the ball started, it's kicked and come back down to the other time. Go ahead and highlight number 2. So number 2 is going to be asking you the same type questions. It wants you to find the maximum height. So remember, you have to find the maximum time and then use that to find the height. And then part B, again, wants to know how many seconds to reach the ground. Again, your ground is 0. When you solve this one, you may have to use a different method in solving that quadratic. If you'll take a look at number 3, go ahead and highlight it. Again, maximum height. You want to find the maximum time and then use that to find your height. So it's a 2-step problem. And then how many seconds to reach the ground. Again, your ground is your height is 0. On the next page, let's take a look at number 4. A penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the following equation, how long would it take it to strike a 6-foot-tall person? So when we're thinking about this, if I asked you how long it would take to hit the ground, our height would be 0. But we're trying to hit a 6 foot tall person. So my height is 6. So I can replace h, my height, in my equation. 6 equals negative 16 t squared plus 1,250. But in order to solve this, I'm going to need to bring my 6 over so that it is in standard form. So in order to do that, I get 0 equals negative 16 t squared plus 1,244. Now when I solve this, I can solve it by putting it in the form where my x squared is on the left. So isolating that x squared. So that square root method we learned. Remember the method we just recently learned where b was missing. So in order to do that, I'm going to move the 16t squared over. So that would give me 16t squared equals 1,244. Then divide both sides by 16. And that would give me t squared equals 77.75 when I do 1,244 divided by 16. Then we find the square root of both sides. And when you do that, remember we get two answers. So we're going to get that t equals negative 8.82 and positive 8.82. But when we think about the problem, it's asking me how long will it take me to get there. Again, it's not going to take you a negative amount of time to get there. So for this problem, it's going to take 8.82 seconds. So a lot of these word problems are reading, interpreting in the information about where you can put it, and then interpreting it with the problem and knowing which way to factor, which method is going to be the best method. If you'll go ahead and highlight number 5, and as you read number 5, again it gives you that equation and it wants to know how long. So it's asking for the time. Will it take the firework to reach the ground? So again, that ground is 0. Your height is 0. Number 6 gives you that equation and it wants to know the maximum height. So we have to find the maximum time. Use that time to find the height, just like we did with number 1 on the previous page. Number 7, it again gives you the equation. It wants to know would Eva reach a height of 14 feet? So in this problem, your height is 14. But you're going to want to think a little bit harder about this because it tells you she's jumping on a trampoline with her height and time modeled by that equation. If she jumped 14 feet, or would she be able to reach that 14 feet? So you're looking at that maximum. So you want to think of it as a maximum problem, but you're still needing to find the height and comparing that maximum height she reaches to the 14 feet. And then number 8, an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the ball 2 meters above the ground. The equation of the baseball pathway is modeled here. The same experiment is done on Earth. So you have one experiment on the moon and the other one is on Earth, modeled by this equation. How much longer would the ball stay in the air on the moon compared to the Earth? So you're comparing, so this is a two-part problem. You're comparing your times on the moon to the time on the Earth. So you want to find that maximum time for the moon and for the Earth and then find out how much longer.